Okay, so welcome everyone joining us today. My name is Evangeline Aritwala, and I am the Alumni Engagement Officer with the CSC alumni team. And I also have my colleague Kirsty Scott, who's joined me today, along with our webinar speaker, whom I will introduce shortly. For today's webinar, we have with us Dr. Vishal Sharma, who will discuss his research on the development of printable solar photovoltaic devices towards achieving net zero targets. And if we can please go to the next slide. Thank you. As you can see, the webinar topic on the screen, and we have Dr. Vishal with us, who is a 2016 Commonwealth Split-site Scholar from India. He completed his PhD in physics from the University of Sheffield and the University of Delhi. Dr. Sharma is currently working as the head of the Department of Electronics at the Government Maulana Azad Memorial College, Cluster University of Jammu and Kashmir in India. He is a trained climate reality leader under Nobel Laureate and former US Vice President Al Gore. And he's also the Global Goals Ambassador at the United Nations Associations of the USA. Dr. Sharma is also one of the CSC's Knowledge Hub coordinators, and he's a coordinator for the Science and Technology for Development Hub. As you will see in his presentation, you can see that he's passionate about providing affordable, clean and sustainable energy to the world and raising public awareness for climate change, which you will see more in detail in his presentation. I now invite Dr. Sharma to present his topic. Over to you, Dr. Sharma.
Thank you. Thank you very much, Eva, for such a wonderful introduction. Namaskar, good morning, good afternoon, and good evening to all my friends across the globe. At the outset, I would like to thank the Commonwealth Scholarship Commission, UK, for the organization of this webinar and given me an opportunity to discuss my views and my experience with all of you. My special thanks goes to Eva and Christy for moderating this webinar. Thank you everyone. Today, I am talking about development of printable solar photovoltaic devices towards achieving net zero targets. As you know, as this is the vision of United Nations to be net zero in the next 20 to 30 years, and I will be going to discuss on how development in this printable solar technology can be help us for achieving this net zero targets. So this is basically the blue marble photo of Earth taken by Apollo 17 mission in December 7, 1972. Maybe all of you wonder why I'm showing this picture to you. And the reason is, actually this picture motivates me always because you can see if you see this picture, you cannot distinguish the boundaries between the countries. You cannot distinguish people, you cannot distinguish countries, and it seems like whole Earth is a one planet, and we are global citizen. And if we think like this, only then we can solve the problems of the world, which are in the form of sustainable development goals by United Nations. So that is the reason why I'm showing this picture. This picture motivates me every time when I will see this picture, this is why this is basically the reason why I'm showing this picture to you, because this will also motivate you to think globally, and for the different problems of the world. If you think globally only, then you can get the solution. Like I'll take one example, like climate change. If you give tons of money to a particular person or to a particular country or a particular region, you cannot solve the problem of climate change, because this is a global problem and this is an interrelated problem. Towards the race to net zero emission, it's not a race to be won this race as compared to other. It is we only won when we reach together. So that is the motivation behind my lecture, that we have to think collectively and globally to solve all these problems of climate change and global warming and all the sustainable development goals if you want to achieve. Now, this is the outline of my presentation. I will start with the United Nations SDGs. What is the requirement of SDG 7, renewable energy? And what is we have to understand the relation between greenhouse gases and climate change. Of course, Paris Agreement and net zero emission. What is Paris Agreement and why we are talking about net zero emission? What are the challenging to achieve this net zero emission, and what are the possible solutions and some of my recommendations? So you can see this is basically the 17 sustainable development goals the United Nations has put together with all the different problems, right from poverty, hunger, health, education, climate change, renewable energy, and all other problems are compiled in different goals, and there are 17 sustainable development goals. My emphasis is on this goal number 7, affordable and clean energy for all. Why I am emphasizing on this particular goal? Because I believe that this goal is the pillar for achieving all the sustainable development goals. Why this is pillar? Because whether you talk of developing country or you talk of developed countries, all the countries, for the development you need basically energy. And at the same time, that energy should not harm the environment. So you ultimately require clean energy, green energy, you can say. So you cannot curtail the energy progress, or you cannot curtail the development, because if you want to develop, you need energy for that, and for this the demand of energy is growing day by day. It's ever increasing demand, and for fulfilling this ever increasing demand, we have to think in a different way. Are we competent enough to fulfill this demand in the coming 20 to 30 years? That's what the motive of this webinar and my presentation is. So that is why I particularly emphasize on goal number 7. So you can see this is goal number 7, ensure reliable, sustainable, and modern energy for all. So why this particular why I'm particularly emphasizing on this particular thing? Because you can see COVID-19 has taught us so many things, like you can see from the data that 1 in 4 health facilities are not electrified. And this data shows us the relation between energy and other sustainable development goals. Approximately 1 in 4 means approximately 25% of the health facilities in the world are not electrified. I am not talking about clean energy or green energy. I am only talking about energy. And if they are not electrified, can you imagine how we are providing health facilities to the people of the world? And most of these people are from poor countries, like and most of them are children and women's. And what about their health? And that's why energy is related to health, energy is related to poverty, because if they are not getting, they are not electrified, the country is not electrifying, even competent enough to electrify their health facilities, the country must be poor. And that's why there is a relation between poverty and energy, and health and energy. So all these sustainable development goals are interrelated. You cannot work on one sustainable development goal and you claim that you have achieved all the 17 SDGs. So that is why I'm showing this picture and this data to all of you. And you can see here 789 million people still lack of electricity in 2018. This is the 2018 data, and 789 million people still lack of electricity. Again, I'm not talking about clean electricity. I'm only talking about electricity, providing electricity to the people. So can you think we have to go a long way to provide clean, sustainable, and modern energy for all the population of the world? You can see from here, this is a latest report, Energy Progress Report 2021, and this is for tracking SDG 7, particularly SDG 7, and it clearly shows that the world is not on the track to achieve SDG 7. So this is the latest report, and report by different climate agencies like United Nations, ARENA, World Bank, and all other World Health Organization. And if you are not able to achieve SDG 7, you are not able to achieve other SDGs also. So that is why this report is very, very important, because we are not at the track. And why we are not on the track, I will discuss in the following slides. No, what is the need for clean energy? So I'll start with greenhouse gas effect, and then what is global warming and how this greenhouse gases can, what is the relation between greenhouse gases and global warming, and renewable energy, especially solar photovoltaic, can be a potential solution for all these problems. So I'm going to discuss all these things, and then you can understand what is the need for clean energy. So I'll start with greenhouse gas effect. What is this effect? Actually, solar radiation in the form of light wave passes through the atmosphere, and it our Earth will absorb it, and basically it heats our atmosphere, and this is the reason for our existence, and this is called basically greenhouse effect. And some energy in the form of light wave trap the atmosphere, but if carbon dioxide concentration is increased in the atmosphere, some of the energy is trapped, and it again heats our atmosphere, and in that way it will increases the total warming of our Earth. Actually, greenhouse effect is very important for our existence, for the existence of human kind in this humankind or other species on this planet Earth. But if we increase the carbon dioxide concentration, which we are doing right now, it will it will have adverse effect on our planet, and that is what global warming is. The global warming is why people are talking about global warming, because carbon dioxide, we are increasing concentration of carbon dioxide into the atmosphere, and this will behave as an envelope to the atmosphere. It will not allow heat wave to trap the atmosphere, and that's why total global warming on the whole Earth is increasing. And that is the reason we have to think globally. In the first slide I told you, because the whole Earth, we are global citizens. We cannot work individually. One country cannot work individually, or one person, one NGO, one organization cannot work individually. We have to work collectively for all this phenomenon. So this is what greenhouse gas is, and this is what global warming is. You can see this is the total energy supply in 2018, and you can see here actually why carbon dioxide is increasing day by day, because we are using fossil fuels for our energy demand. And this oil and coal, you can see approximately more than 70% of the total energy supply till date is dependent. We are more dependent on fossil fuel rather than other form of energy. So that's why we are increasing carbon dioxide concentration into the atmosphere, and that's why we have to work on that. And we're talking about clean energy and all that. So carbon dioxide is being released into the atmosphere faster than any time in at least the last 66 million years. So we are producing carbon dioxide into the atmosphere like anything. And it is equivalent to basically 500,000 first generation atomic bombs per day, 365 days per year. This is a statement from NASA. Can you imagine, can you see how much carbon dioxide we are releasing into the atmosphere? And that is why the basic reason, the main reason, the major reason for the global warming all over the world. So there's again a data 19 of the 20th hottest years in the last century. We are witnessing all these different years, and 5 of them in the last 5 years. You can see 16, 17, 19, 20. So all these are the hottest year of the century. So this is again a very wonderful phenomenon of global warming. The same extra heat that evaporates more water from the oceans, causing bigger downpour and floods. But at the same time, this extra heat will pull more moisture quickly from the soil, causing longer and deeper droughts. So actually what happened, due to global warming is a two-edged sword. At one side, at one part of the globe, we are witnessing a lot of floods, a lot of rain, and on the other side of the globe, we are witnessing a lot of droughts. So it's a two-way sword, and that's why it's a worse condition. It's not only causing only floods. On the other hand, it's causing floods, more water in the planet. And on the other side, it causes a lot of drought. So that's why it's very global warming. We have to think globally on this. So these are different phenomena happening all around the world. This is temperature 52.2 degrees centigrade 2019 Kuwait temperature. This is Canada, forest fires, Tamil Nadu, India, a lot of floods. And this is the latest Canada, 29th of June, 2021, 49.6 degrees centigrade, and more than 500 people died in this Canada heat wave. So this is the phenomenon all around the world. This is due to global warming and climate change. Climate scientists shocked by the scale of floods in January. This is also latest news. A lot of floods in January, Germany, and this is all because of climate change and global warming. Again, World Meteorological Organization found that the temperature of Antarctica, it's 18.3 degrees Celsius. And earlier, the record is 17.5 degrees Celsius. It's all due to global warming. The increasing, the temperature of Antarctica is increasing. So it's in 2015, 17.5, and 2021, it's 18.3. So all these phenomena are claimed that this climate change and global warming is a real situation. And you can see Stanford University, they claim that what are the effect of this global warming and climate change on crops. Still, a lot of research has to be done on this particular thing. What is the relation between crops failure and climate change and all that? Now, 90% of the climate scientists agree that climate warming is extremely likely due to human activities. And 67% of the total emission by fossil fuels, and most of the developed countries are, they are responsible for this. And therefore, reduction of carbon dioxide emission and universal access to affordable, reliable, and sustainable energy is very crucial for achieving all the sustainable development goals by United Nations. So what is, now we'll talk about Paris Agreement. What is this Paris Agreement? It was adopted by 196 countries at COP21 in Paris on 12th of December 2015. And what is the goal of Paris Agreement? Is to limit that global temperature by 2 degrees centigrade or 1.5 degrees Celsius compared to the pre-industrial level. Why they have targeted on this particular temperature 1.5 instead of 2 degrees Celsius? Because it could result into fewer million people being exposed by severe climate change and effects. We can still save some people from climate change and global if we target on this particular temperature. And most of the countries agree to phase down their greenhouse gas pollution and achieving net zero emission as early to the second half of this century. That is up to 2050, and we have only 29 years left for this. So what is net zero emission? What actually net zero emission is when the total emission of a particular country is equivalent to the total absorption of that country. So this is called net zero, because I already told you that we are developing countries, and we have to focus on development also. And for development, you need energy. And of course, still, if you talk today, we are 70 to 80% energy is used by fossil fuel, and we cannot change energy in one day. And we can shift from non-renewable energy to renewable energy in a very short span of time. So net zero emission means, if you are meeting, if we're talking of particular country, if they are emitting some energy of carbon dioxide in the form of carbon dioxide, the total absorption and emission should be equal. So that is what the net zero target is. So what are the challenging across the road for this net zero emission? So first is annual rate of electrification. At the current rate of electrification, a projected 620 million people would still lack of access to electricity in 2030. We are, electrifying different regions of the world at a very fast rate, but still we are not so fast, because 620 million would still lack of access to electricity in 2030 if the same pace and same policies are there. So again, I'm not talking about, clean electricity is only electricity. So you can imagine if you have to provide clean electricity to every population of the world, how much pace we have to take. So again, second point is clean cooking solutions. Approximately 1/3 of the world population depend upon fossil fuel for cooking, and this is also biggest reason for releasing carbon dioxide into the atmosphere. So this would affect mostly women and children's will continue to be exposed to harmful air pollution. So we have to provide clean cooking solution to this much amount of people. So that is also the biggest challenge in front of all of us. And third point is the transport sector. Again, this is the biggest challenge, because transport sector, there are different type of transport, and road transport is the biggest cause of pollution, because it's approximately 70 to 80%. We have air transport and other forms of transport, but road transport is the major chunk, and we have to focus on road transport, and it accounts for 96.3. It takes about fossil fuels 96.3, and only renewable only 3.7%. So we have to focus on transport sector. It's also a big challenge to replace with renewable energy to this transport sector. So these are basically the different challenging across the road. And I think climate change is not at the priority level globally, you can see. And this is again a different challenge for all of us. If you talk of 2016, only 6 countries has some carbon neutral ambition. And in 2019, 67%, 7 countries, they have some plan for carbon neutral ambition. And only 8 of them has some concrete robust policy for that. So you can see climate change is not at the priority of different countries. And if it is not a priority, this is also biggest challenge in front of all of us. So we have to convince, this is also our job, to convince the government of different countries to to have climate change in their priority, in their policies, and so that they can think over it and they can find some innovative solutions for this. So this is again a different challenge for all of us, how to convince the governments of different countries across the globe. You can see investment. This is a global investment to take out different countries to economies due to which are there COVID-19, because of COVID-19. And this is a sustainable recovery tracker report. And we found that only 2% of this global investment is on clean energy. So if there's no investment, people are not willing to invest money on clean energy, governments are not willing to put climate change on priority, and we have different other problems. So how can we achieve net zero targets? I don't know. So we have to think all this. These are the different challenges in front of all of us, and we have to overcome this challenge in we have very less time actually. We have only 30 years to overcome all these challenges. and save our Mother Earth. These are different countries on net zero path by 2050. And you can see the data, 2 countries have already achieved net zero target. Why they have achieved? Basically, they are small countries and population is very less and forest area is more. That's why they have achieved net zero target. But other countries, they are planning for that. They have different plans. They are making some legislations for that. And you can see even China, it claims to be, because China, India, they are biggest polluter in the world. So they are making some plans. Their policy document, they are making some policy document, they are making some concrete plan how to be net zero up to 2050 or 2060. All our different countries are also planning, but again, I told you that they don't have any concrete plan how to. I already told you there are 3 different sectors. We have to give some clean cooking solutions. We have to think over transport sector. They are the major, contributor to carbon dioxide into the atmosphere. So we have to find some policies. We have to find some concrete policies for all of this. So achieving net zero emission by 2050 will require nothing short of complete transformation of global energy system. So that is what is required. Complete transformation of global energy system. Are we ready for that? Are we have some concrete policy for that? That is biggest question in front of us. Are we ready to tackle different obstacles in front of us? So that is the biggest questions in front of us. So do we have solution in hand? We have already talked about different challenging, different problems, but what is the solution? This is my personal view, that development of solar photovoltaics has an alternative to fossil fuels and coal. Most of the energy in this world is, most of the countries are dependent on fossil fuel and coal. And if we, I believe that solar photovoltaics has the potential to replace fossil fuel and coal. But with existing technologies, I don't know, I'm not very sure, but naturally with innovative technologies or new different technologies, we can have the solution. Of course, finding innovative solution to make solar more accessible and reliable. We have to find, if we talk of only solar, we can find some innovative solutions to make solar more accessible and reliable to the general public. And printable solar photovoltaics could be the best solution to achieve net zero targets as envisaged in Paris Agreement. So if you talk of net zero targets, of course, printable solar photovoltaics. This is a new technology which I'm going to talk about in my next slides. Has the potential to achieve all these net zero targets. So let's talk about solar photovoltaics. So why I am talking about solar? I'll tell you one thing. In India, I'm from India, and in India we consider solar as a god. And in my childhood, I was wondering why we are considering solar as a god. Now I realize that solar has a capacity to provide clean energy to the entire world. And you can see from the data, enough solar energy reaches Earth every hour to fill all the world energy needs for a full year. So solar you can fulfill the demand for a full year in just 1 hour. But we require to find how to trap this energy. And that is what solar photovoltaic is. So solar photovoltaic, also known as solar cell, it's also called solar cell or solar device, solar photovoltaics. Basically, it converts sunlight directly into electricity. And how it converts sunlight directly to electricity, this particular effect is called photovoltaic effect. All of you might be aware of, Einstein is the biggest, top scientist of the last few centuries. He has invented, a lot of things. He's the founder of a lot of, formulas, a lot of like relativity. It's the main. People know him because of relativity, but you are surprised to know that he received Nobel Prize for photovoltaic effect, not for relativity. So that is so important effect, photovoltaic effect. What is that effect? Actually, Einstein is the person who explained the photovoltaic effect, how sunlight converted directly into electricity. And this is what the solar photovoltaic is. And that is what the solar cell does. It converts sunlight directly into electricity. And currently the most popular solar photovoltaic device is silicon photovoltaic solar cell, or silicon technology, you can say. Now, what is this silicon technology? So silicon is the most commonly semiconductor material used in solar cell, and all, of course, other devices also. If you are background of physics or electronics, you know that silicon is the basic material for all the electronic devices. And silicon solar cell approximately representing 95% of the solar modules sold today. So at least solar photovoltaic technology has overcome the whole solar industry nowadays. It has different forms. I'm not going into detail of all technicality of all this. There are thin film solar cell, monocrystalline, polycrystalline. There are different forms of solar cells. But the problem is, what is the disadvantage of this? Why this, all this popular in the world? Because we don't have any alternate full put technology than silicon solar cells. But it's not, it has some drawbacks also. What is that drawback? You can say disadvantage of silicon solar cells. It is basically, you know, it is very costly technology. Its cost factor overrules its advantage with the efficiency. Why it's costly? If you know a little bit of chemistry, you know that silicon, when comes into direct contact with oxygen, it converts to silicon dioxide, and which is an insulator, and it's useless for making solar cells. So you cannot make solar cell in the ambient atmosphere. What is ambient atmosphere? In the room temperature and pressure. So for this, you need some sort of sophisticated clean rooms and globe boxes to make all these solar cells. I'll show you the pictures. Like these are some clean rooms and globe box facility. You can make all these solar cell in these clean rooms and globe boxes, and you can see you have to wear different clothes for that. And that is why, because you need some sort of sophisticated clean rooms for that, for making silicon technology, and that is why the cost is very, very high. And another point is, as per the US Department of Energy, the world requires 45 trillion kilowatt of electricity in the next 30 years. So based on the current trend in silicon photovoltaic manufacturing, because you are manufacturing this silicon solar cell in the clean rooms and globe boxes, it will take another 100 years to produce this much amount of electricity. So how we can talk of achieving net zero targets up to 2050 or 2060 if we're not able to provide clean energy solutions to the world? So that is the biggest problem we have to make. So we have to find some alternate technology which we can fabricate in the open atmosphere without the need of any clean rooms, globe boxes, and of course, which can be very, very cheap. That is reliable and accessible to the general public. So my open question: can we fabricate low-cost, electronics or solar devices in a sophisticated clean rooms or in globe boxes to fulfill the requirement of the entire world? And my answer is no, we cannot do that. So that's why we have to search for different technologies. And yes, we have some alternate technologies for that. And printing technology is one of them. Ambient condition fabrication of electronic devices through printers. Can you imagine to take printout of a solar cell from the comfort of your home, your space, from the printer you have in front of you or on the back side of you? It's very, it's hard to imagine at this time, but it's very much possible. And there's a statement from US Department of Energy that if 50% efficient perovskite solar cells, perovskite is a material which is used for making solar cells like silicon, if printed at the rate of newspaper printing, would fulfill the demand of entire world in 3 years. And that is a very great statement. If I able to make perovskite solar cell with 15% efficiency, I'm not talking about 20, 25, 30, only 15% efficiency. And if printed if we are able to print that solar cells like newspaper printing, we can fulfill the demand in just 3 or 4 years. So that is the biggest statement. And yes, printable solar cell has the potential to provide clean energy to the entire world for achieving net zero emission targets. So as a Commonwealth scholar, I have developed printable ink in the ambient condition, which is an important factor for the development of printable perovskite solar cells. Actually, for printing, what you required, you have inkjet printer, laser printer at your home, in your offices, and you require ink for that. If you are able to make ink, that is the first step in making printable solar cells. So as a Commonwealth scholar, I'm fortunate enough to develop that printable ink, and that too in the ambient conditions. Ambient conditions being at room temperature and in the normal conditions. No need of any closed box, no need of any clean rooms and all that. So that is very important factor for changing development of printable solar photovoltaic devices. No, some background of printing. First printing machine is invented in 1440, and it revolutionized the way the information is spread across the world. And I'm sure if we are printing, nowadays every a lot of research scientists are basically focusing their research on printing electronics and printing technologies. And it will definitely revolutionize the way energy is spread across the world. So I am very much sure that we are able to develop this, commercialize this technology for the benefit of society and the world as a whole. So what is printing electronics? Actually, it refers to the use of printing techniques to produce electronic circuits, components, devices in a wide variety of arrays such as paper, plastic, glass, metal, textile. You can print anything on any substrate. You can you have if you are able to make printable solar cell, you can print it on your curtains. You have a solar curtains. You have solar windows. You can coat solar cell on your cars. Vehicles. So there are a lot of application if you can print solar cells. So that's why I'm talking of printing tech, and you can print very fast. So that is the reason why I'm very much sure that printing technology has the potential to make net zero targets, to achieve net zero targets. So what are the advantages of printing technology? Yes, of course, the cost is very less because very few materials used. Performance is improved, flexibility is there, lightweight. You can make lightweight devices, solar cell. You can send it to space. Transparency, you can make transparent devices for that. Reliability is there, and manufacturing roll-to-roll process. This roll-to-roll means you can the printing of newspaper. This roll-to-roll technique is used. So if you can manufacturing roll-to-roll, you can achieve target in 3 or 4 years. Of course, it's good for environment because very less material wastage is there. So these are different substrate. People are working on that. They are making solar cells on graphene, CNT, and other substrates. There are various printing and coating techniques. So spray printing, blade coating, offset, dip, inkjet, screen printing, type slot die. There are a lot of printing techniques nowadays. But last focus is roll to roll. Only then we can fulfill the demand of the whole world. So roll to roll is the focus, but we have to search different techniques, different printing techniques also. This is a roll to roll from one of our research paper. Roll to roll technique, you can see this is a printable solar cells, and this is blade coating, slot die coating, spray coating, screen printing, inkjet printing. There are different printing techniques. And this is roll to roll printing. You can see a diagram here. This is how solar cell is made roll to roll. And this is a blade coating perovskite solar cell. I'm working on this at NREL, National Renewable Energy Laboratory. You can see this is a prototype for roll to roll. If you are, because you cannot directly go to roll printing because you require a lot of material for that. For optimization and making solar cell at your lab, you can optimize on this machine, and this is called blade coating machine. And if you are able to make solar cells on this blade coating with fair enough efficiency, you can then transform these parameters directly on roll to roll, and then you can achieve roll to roll printing with solar technologies. So that is what our machine look like. And this is inkjet printer where perovskite solar cell can be printed. Like this is inkjet printer you have in your offices or houses. And this is some of the flexible electronics developed by me, solar cells developed by me. Now, what are the challenging for printable perovskite? So I'm not going into technical detail of all these things, but first challenge for printable perovskite solar cell or printing of any electronic device. First, you have to develop ink in the ambient conditions, because printing technology is for ambient condition manufacturing. So first you have to prepare ink for that, and that is the first challenge. If maybe you are working on silicon, you are working on perovskite, you are working on any other material, solar material or any other different material. First, you have to make ink in the ambient condition. And if you are able to make ink of that material to be used in different printing machine, the half of the work, you can think half the work is done. So first challenge is development of ink. And second is selection of suitable printing technique, which there are a lot of printing technique. You have to select, and it all depend upon your goal, what you want to achieve. If you want to definitely if you want to achieve roll-to-roll printing, then you have to, I already told you, you have to work on the prototype like blade coating, or you can also start with slot die and all that. Optimization of different layers. Of course, like in solar cell, we have 3 to 4 layers, and the optimization of all the layers is very necessary. Because maybe some of you are working on solar or other devices, optimization of one layer, it's a challenge for all of us. So optimization of different layers is very important. And the biggest challenge is you don't have any data in your hand, ready-made data in your hand. In other techniques, you have some data at least to start with, but in printing, this is a new technique. So you don't find the literature for this. You have to start fresh. So that is the biggest challenge, how to start afresh with different layers. Of course, optimization varies printing parameter. Then you have to optimize different printing parameters. What is the speed for that? How much material you have to put? What is the solvent you have to use so that it doesn't dissolve other layers? So these are different problems you can find in when you optimize different layers and different printing parameters. And of course, in the last, when you're able to make device, you have to test it in different conditions, maybe in open atmosphere and different humidities, or how your device will work in different temperatures, different pressures, so that it can be used all over the world. So what are my recommendations to win net zero emission? So first focus is on award. What is award? This is awareness as well as research and development. So this is my first recommendation. You need not to be only work, if you want to, if countries really want to be net zero, the two things are very important. First is awareness. For any mass movement, this is my personal view, for any, big transformation, great transformation, public awareness is the key to success. So public awareness is very, very important. If public awareness is there, only then public can convince the, heads of the governments to have climate change in their priority list. So public awareness, public understand. So we as a climate communicator or a science communicator, we have the responsibility to make people understand that climate change is real. It is happening all over the world, and we the people of this planet, we are responsible for that, and we have to work in this direction also. We have to, we need a full transformation of energy system. And for this, we have to find some innovative and, new solutions for that. So public awareness is the key to success. That's why the first emphasis on the awareness of the general masses. And second point is research and development. We have to develop new devices. You have to develop new techniques, new technology to replace existing technologies if we are not able to fulfill the demand. So that is two important things that I will recommend: awareness as well as the research and development. Of course, printable solar cell could be the possible alternative, as a printable solar cell have the capability to fulfill the entire ever increasing demand of energy. I already told you, if you can print solar cell like newspaper printing, you can fulfill the entire demand because solar energy is abundance in the world, and it is almost everywhere. We can also explore the possibilities of hybrid technology. Yes, it's a very important. Two important factors like solar energy and wind energy. In my view, I'm particularly focusing this webinar on solar, but wind energy is also an option. But sometimes some countries we have very much wind energy, but we don't have solar. Somewhere we have solar energy, we don't have wind, or somewhere we have hybrid of this. So we have explore the possibilities of hybrid technologies, maybe integrating solar with wind or solar with other technologies. So, we have to explore the possibilities, innovate new possibilities of hybrid technologies. And one of the key pillars for reaching net zero emission is using energy more efficiently. That is also, and that covers under awareness section. We have to teach people how to use energy more efficiently, how to make our houses more efficient, energy efficient, so that we can use less energy. We can use daylight energy in daytime, so we can save a lot of energy. So we have to, again, awareness is a key factor in this direction. We have to how to use energy more efficiently. And last point is social cost of carbon. That is also this is a magical number, social cost of carbon. Actually, what happened when you emit carbon dioxide into the atmosphere, actually we are paying for that. Directly or indirectly, we are paying, and there's a social cost associated with the carbon. It depends upon countries to countries and government to government. What is the social cost? Earlier it was $50, and now it is $1. It all depends upon how they calculated the social cost of the carbon, how much carbon dioxide is harmful for the countries. It all depends upon different factors. But of course, there's a social cost associated with the carbon dioxide emission. So we have to make people, again, awareness is very important. We have to convince people, we have to make them aware that when you are releasing carbon dioxide into the atmosphere, you are paying something. Or in other words, you can say that if you are not releasing carbon dioxide into the atmosphere, you are saving some amount of money. So there is a social cost associated with carbon emission, and we have to tell the people. We as a climate communicator, we as a science communicator, has a responsibility to tell the people that there is a social cost associated with the carbon dioxide emission. So these are some of my recommendations. And my final recommendation is in SDG 7. I'm not sure I'm right or wrong, but in SDG 7, if you read Sustainable Development Goal number 7, it says that ensure access to affordable, reliable, sustainable, and modern energy for all. But there's one word missing: secure. Because all of you know that people are working on alternating energy, like nuclear energy, hydrogen energy. I don't know, I'm not expert in nuclear energy or hydrogen energy, how much safe it is for the world, I don't know. But if it's not safe, we have to find safe and secure alternatives to the fossil fuels. So my recommendation is to use word secure in goal number 7, because it is missing, and because we have to provide safe and secure energy in relation to affordable, reliable, and sustainable energy, modern energy for all. So this is my last and final recommendation. Now, my ongoing work, of course, as a knowledge hub coordinator for Commonwealth Scholarship Commission, as a former Commonwealth scholar and a alumni of Commonwealth Scholarship Commission, as a global goal ambassador for renewable energy and climate change for United Nations Association of USA. I'm doing some work, and I'm organizing climate-related international webinars, conferences. I'm involving students, stakeholders, or other persons, contributing by writing articles in newspapers and academic journals, motivating young generation to become climate ambassadors, of course, climate communicators. And I have also started my Facebook page, INT SOAR Labs, to create awareness on climate change and renewable energy. And this is the link for that Facebook page. These are my son, and I will invite all of you to involve in all these activities with me, and I am happy to welcome all of you. And thank you very much. Welcome to a world powered by printable solar photovoltaic devices. I'm open for now questions. To save the planet, change the way we use and make energy. And this is my email ID. You can connect me on this email, my Facebook page, my LinkedIn page, and you're welcome for questions. I'm ready to give the answer if I am able to give. Thank you. Thank you very much. Thank you.
Thank you so much, Dr. Vishal. had a brilliant presentation on your research area. And me personally, for someone who's not from a science background, you gave a really great understanding on some of the key concepts related to climate change and your research study. So thank you so much for your presentation. You have also helped us understand the importance of developing an alternative solar technology to mitigate some of the risk involved as part of climate change and global warming. And I do hope that the attendees attending this webinar today can relate to some of the key points that you mentioned during your presentation. And I do invite the attendees to send in your questions using the chat function. I do have a couple of questions that have come in the chat box. I will invite Raphael from our attendees to ask your question. Raphael, if you can just unmute yourself, please, to ask your question to Dr. Vishal.
Thank you, Eva. Thank you, Dr. Vishal, for this wonderful presentation. I'm very much interested in climate change and what we can do to mitigate it. So my question to you is, can the achievement of net zero by some countries mitigate the current global warming and climate crisis that the world is facing?
Oh, sorry, Rafal, I'm not able to understand your question because there's an interruption in your voice. Can you repeat it? I'm sorry for that.
Okay, sorry. I said, can the achievement of net zero by some few countries mitigate the current global warming and climate crisis that the world is facing?
I have already told you this is race to net zero, and the earlier winner is not the winner of this whole globe. We have to run together. Actually, it's not a game of first, second, third. It's a game of reaching together. If some countries, like I already told you, 2 of the countries already achieved net zero because of their low population and more forest area, but it doesn't solve the problem. We have 5 to 10 developing countries who are most exporter of carbon dioxide into the atmosphere. Of course, when they can achieve net zero, some problem may be solved. But as a whole, we have to come together. Only then we can solve the whole problem of climate change and global warming. So actually, in my view, we have to come together and we have to work together, and we have to achieve net zero together. Only then we can solve the problem. It's not a question of 1 or 2 countries. I hope you will get the answer.
Thank you, Doctor. Thank you.
Thank you.
Thank you, Dr. Vishal. I have a question from Tajweer. I hope I'm pronouncing your name correctly. Tajweer is asking if what are your views on the life cycle assessment of PV cells to eradicate effects of global warming? Is disposable phase also carbon neutral?
Yes, you are right. Very good question. Actually, yes, of course. If I am talking of perovskite, I'll just taking in perovskite we are using lead in that, and which is also harmful for the climate. We have to find okay, it's solar cell as a whole, because why we are solar cell? We are using solar cell for this because this is carbon neutral. The energy we required, in the manufacturing, we release some carbon dioxide in the manufacturing of cell is equivalent to is less than which we are absorbing in the whole cycle. So disposable of solar cells is another question, and you are right. We have to think solution for that also, because if we are producing solar cells like anything, and after 30 years, where we have to dispose it, we have to find some disposable solutions to this also, and this is another domain where people are working on. In perovskite, I already told you, people are working on to find alternative to lead because it's very harmful. Although we are using very less, 5% in the whole structure, but still its lead is available. And we, when we dispose perovskite solar cell or printable solar cell into the soil or somewhere else, it will harm the environment. So we have to find 100% clean solutions for that, and that's why R&D is very important. So yes, of course, we still would not have any solution. We are working on that, but in future maybe somebody will come up with some solution. Yes.
Great. We have a couple of questions from Izingbe. So I'm going to invite Izingbe to ask probably 2 questions that they have asked. If you could please unmute yourself, Izingbe. I hope I'm pronouncing your name correctly.
Yes, yeah. Thank you very much. Dr. Vishal, thank you for a very wonderful presentation. I think it's needed even at this time because many countries, especially in Nigeria, where I'm from, are relying on solar power now because the national grid are not very, very reliable. My questions, I'll just ask a couple of them. Is basic, they are linked. It deals with the production of this ink and the availability. The first question is, the inks for printing the solar PVs, are they currently available on a commercial scale? And is it easy to manufacture the printers, or you can use a regular paper printer for them?
Yes, because the ink which I have developed, it is through ball milling technique. If you are physics background, maybe you understand what is ball milling. It's very simple technique to make nano materials. You can have some, it's like a small box, of course, iron box, and you can put some zirconia balls in that with some material, and you can roll it for 2 hours, 3 hours, depending upon your material, and you will get some material out of that. So it's a very simple techniques, a room temperature technique, and yes, it's commercial, and you can make it in a large scale in the industry. So that's why it's very easy to develop. Of course, for if you want to be, I told you, if you have to make solar cells in a very large scale to fulfill the entire demand, you have to make it very fast, and for that you have to make basic ink very fast. So ball milling technique is a very good technique and very easy technique, and it's commercially you can make it very easy, not very costly also. So that's why, because if ink is costly, you cannot make solar cell less expensive. So it all related. So ink is we have developed that ink at a large scale. We can develop it at a large scale, and then you can make solar cell out of that with printing techniques. Yeah, of course. Yes.
All right. Thank you very much.
Okay. Thank you.
Thank you, Zingbe, for your question. I'm slightly concerned about the time, but we do have some interesting questions. I'm going to quickly run by the questions to you. This question is from Frederick. How do printable solar voltaic cells compare to regular solar cells in terms of efficiency, and what material, and by material they mean metal or plastic, must they be coated on to attain the efficiency?
Yes, actually, if you talk of this is printing and silicon, these are 2 different technologies. In silicon, the main absorber is a silicon, and you have some electron transport layer which you can extract the electrons, some hole transport layer where you can extract the holes, and same phenomena in printing solar cells. You have some substrate and then you have 1 layer electron hole transport layer, then you're absorbing material whole transport layer, and then metal oxide. So this is the whole structure. It's almost same. It's only difference is only in the materials. And in terms of efficiency, of course, silicon has the highest efficiency in the world. Not in the world, sorry, they have other materials also, but for commercial purpose, silicon is has the highest efficiency. It's 22 to 24 or 25 in lab scale, and in the commercial it is 20%. For perovskite, it's also, if you talk of, I'm not talking of printable solar cells. If you talk of perovskite solar cells only, that can be manufactured with different instruments like spin coating and other techniques. We have achieved 23, 24 in the lab. But with printable, I have achieved fully printable solar cell People are talking about, sometimes people, they will print only one layer and they call it a printable. It's not printable. Printable is when you print, when you're able to print all the layers. So with all the layers, I personally got 13% efficiency, which is not very, excellent, but it's not very bad. I told you 15% efficiency is our goal. So if we are able to achieve 15%, even in my view, this is my personal view, if not 15%, I think, if you talk of plants, they have only 2 to 3% efficiency, leaves. So if we are able to develop 10% efficient solar cells, but they are so cheap that you can replace it, that you don't have any, problem in replacing it frequently. And I think that is okay for that. So 10 to 50% is a good enough efficiency for commercialization. But of course, you can produce it very fast. So that is the main goal. So that is the difference between different efficiencies and their structures. Yeah, thank you.
Thank you so much for your response to that. We are running slightly over time, but I do have an interesting question from Mattia. So that would be the final question for this webinar. Mattia, I hope I'm pronouncing your name correctly. If you could just please unmute yourself to ask your question.
Thank you, Eva, for this opportunity. My name is Mattia from Aberdeen. Doctor, I would like to say thank you for your great work. And my question is about how durable the printable solar, because if you are going to be printing, I think it should be something that will last for some good number of years so that can be used fully. We avoid the accumulation of wastes. So if Doctor, you could answer me about that, the durability, that will be fine.
Sorry, Mattia, actually, I'm not able to understand your question fully because of interruption. But what I have understand, you are talking about durability and I think stability you are talking about.
Yes,
right? Yes. So yes, if you talk of stability, of course, it's not so stable because silicon solar cells has 20-year lifespan. But for perovskite, which I am talking about, earlier, organic solar cells maybe thought of replacing silicon, but the stability is very, very less, maybe in hours or few days. But for perovskite, it is, you can say, which we have developed. I tested it for 6 months and it's quite stable in open atmosphere. We are still testing the stability. I'm in India, but people are working there and they are testing stability. We have to publish that paper. So what we think, and they are not, they are not encapsulated. We encapsulate it. So if you can encapsulate it, we have to encapsulate it also. It will again enhance the lifetime. But without encapsulation in the open atmosphere, you put because when you put it, when you commercialize it, you have to encapsulate it with different one layer, so to protect it from the direct environment. So encapsulation solar cells has different lifespan. But if you talk of bare solar cells, 6 months already we have already tested. It lasts for we think lasts for approximately 1 or 2 years more. I don't know, maybe more than that or maybe less than that. So stability is okay. We have to achieve at least 5 years. So again, this is not my domain to work on stability, but still people are working on this domain also to enhance the stability by different techniques. So of course, maybe in near future, we are able to get stability within 3 to 5 years or more than 5 years. Thank you.
Thank you so much for your question, Mattia. And with this, we come to an end of our presentation today. Thank you once again, Dr. Vishal, for your amazing presentation, which highlighted your work as a CSC scholar. And I'm sure our attendees have been influenced with not just your work, but also in terms of the message that you have conveyed throughout the webinar, which is working in unity, towards this challenge. So thank you so much for presenting this topic. I would, sorry,